Here we're asked to solve these inequalities with the logical OR in between them. So there's going to be a lot of solutions to this. Let's first solve each one of the inequalities separately. Alright, so if we add 7, here we get 2x is less than negative 2. Dividing by 2, we get x is less than negative 1. Or, now working the second inequality first by subtracting 1, we'll have 3x is greater than or equal to 9. And then dividing by 3, that leaves us with x is greater than or equal to 3. Okay, so this is our answer. Any numbers less than negative 1 or any number greater than 3 should solve the original inequality. So we're going to think of that as a union of sets. So let's choose a good scale. Let's say zeros here. We have 1, 2, or negative 1 out this way. Now what we're going to do is shade in all these numbers. So anything less than negative 1 should work. So I'm going to use an open dot here and shade in anything down there. Okay, so that's all the solutions for the first inequality. All those numbers will solve that first inequality. Okay, or we're also going to add, we're going to take the union of all the numbers greater than or equal to just 3. So here, since we had the equal, I'm going to use a closed dot, and I'm going to shade in everything greater than 3. So all the numbers less than that, or all the numbers greater than 3. So to translate this into interval notation, I'm going to write interval notation from negative infinity to negative 1 with a parenthesis there because we had an open dot. That's the translation of the left tail. Or we're going to write union, set notation, looks like a horseshoe there, inclusive 3 off to positive infinity. Okay, notice that was a closed dot, so we're going to use a square bracket. Okay, so this would be the equivalent interval notation where OR translates here as the union of these two sets.